Hello everyone. So this is the second part of numerical solution. So this will contain from question number 11 to question number 25. So we will see one by one. So let us take a 11th number question. So in 11th number, what is there? Like a fan consumes 200 watts. So power rating of a fan is 200 watts. Okay. So we'll convert into a kilowatt. That will become 0.2 kilowatt. Now they are saying electricity per hour. They are saying. Okay. Now, and a person uses fan once a week. So in once a week for 24 hours. Okay, once a week and 24 hours. So in 1 week he is using 24 hours. So okay. So what is happening now? They're asking like how much roughly he has to pay the owner the electricity bill if the value of one electrical unit is 5 rupees. Okay, so on monthly basis how much he has to pay. Now, so in a month there is a 4 week. So if you calculate for the hours, then 24 into 4 weeks. So this will give you how much? This will give you around 96 hours. So you know one electrical unit is equal to kilowatt hour. So already you know 0.2 kilowatt hour is there, 0.2 kilowatt, and hour is 96. So if you multiply by this, it will become 19.2. So for cost purpose, for one unit, they are saying they are taking how much? 5 rupees. So if they are consuming 19.2 unit, okay, in that case 19.2 into 5. So that will become around 96 rupees. So a man who is using a fan for once a week for 24 hours in monthly basis he has to pay 96 rupees. Now the next question is a transformer of step down type has a power available of 1000 kilowatt at the primary winding having copper wire resistance of 10 ohms. What will be the power available at the secondary winding after the step down taking place by means of mutual induction process or principle? Neglect all losses. First of all, they are mentioning here neglect all losses. So you have to avoid all the hysteresis loss, all the iron loss, copper loss. So in that case, the transformer is called as, in that case, if no losses is there, if no losses, the transformer is called as ideal transformer. Actually this will not exist anywhere. Without losses we can't construct any machine at all. So here is a step down transformer. No, everyone is rushing to calculate how much, but thing is that they are saying in primary winding there is a power available is 1000 kilowatt, and in secondary winding power is how much? So one thing, transformer transformer is device which is used for power transmission means only he has to transfer the power from one place to another, so there will be no change in power, unless on the secondary thing is that V and I is getting changes, V value and I is getting changes. So in case if they're asking primary winding is having this much of power, what will be the power available at the secondary winding? In that case, whatever will be available in primary winding, the same will be there in secondary winding, because there is no losses taking place. As they already mentioned, neglect all the losses. So the answer for this is 1000 kilowatt only. Whatever it is present in primary, that will present in secondary also. So no need to solve and no need to waste your time. So I will suggest you just read question once properly, then proceed for any solution or anything. So then the 13th one, you can see a potential transformer. Can you say what is potential transformer? So potential transformer is something else. In case if you want to measure a heavy voltage, in that case you can't use a measuring instrument, okay, direct small measuring instrument, that will damage that instrument. So what we are doing, we are taking that heavy voltage out connection and we are converting to a low voltage. Okay, HB we are having high voltage, and we are stepping down to LV. Okay, and in LV we are connecting a voltmeter. So take an example. We are having a primary winding like this, okay, and we are having a secondary winding like this. We are having a voltmeter. We are having a voltmeter here. We are having a voltmeter here, okay, and this is supply. Now in this case they're asking a potential. This complete setup is potentiometer. This complete setup is potentiometer, potential transformer. So used to measure high voltage. If the primary and secondary coil has a number of turns 100 and 10 respectively, so they are saying the primary coil is having 100 turns and the secondary coil is having a 10 number of turns. So n is equal to 10 here and n is equal to 100 here, we know, okay. So we know the transformation ratio n1 by n2 is equal to v1 by v2 is equal to i2 by i1. So we will take this equation out. We will take n1 by n2 is equal to v1 by v2. Now we can see here and a voltage measured by the means of voltmeter across the secondary winding is 440 volts, and when we measuring the voltage, this is giving you output of 440 volt. So now they are asking then what will be the voltage across the primary winding. So what will the voltage across a primary winding? So how you will do? So n1 we know, n1 value we know, n1 value we know. Always consider 1 for primary coil and 2 for secondary, and n2 value we know. So n1 is equal to 100, n2 is 10. Voltage we don't know, primary voltage. Secondary we know 440. By making a cross multiplication, 440 into 100 is equal to 10 v1. Okay, so here 44000 by 10 is equal to v1. So if you cross this one, this will give you 4400 volt, which is nothing but 4.4 kilovolt. This is your option, okay. So your option for this correct answer is 4.4 kilovolt, okay. So we will move to the next question. So next question, 40 number. So for what the question is saying, just say calculate the value of shunt, okay, calculate the value of shunt connected in parallel with a galvanometer to make the complete setup to work as an ammeter when the I value is given as 10 amperes and Ig, which is the current flowing through the galvanometer, is 3 amps and the basic meter resistance stated as 5 ohms. So they have given you the galvanometer resistance, they have given you a current flowing through the galvanometer, that is the Ig, and the next the total current, the capital I, is given as a 10 ampere. Now we'll draw first circuit of a arrangement of a ammeter. As we know, if you are having a galvanometer and if you connecting a shunt in parallel with that galvanometer, then complete setup, this complete setup will become ammeter, okay. So in that case they are saying that I value, they have given the I value, see, 10 amperes. Now Ig they have given you 3 amps, okay, fine, and the resistance Rg value they have given you 5 ohms, and this is the S, we have to find S only, this I we have to find, and here is the current flowing, that is I value, Ig is flowing there, so here will be current I minus Ig. Now if you see carefully, this galvanometer and this shunt is in parallel connection, and we know that in parallel connection the voltage across, where the voltage drop across the resistance or a load is same. So we will take a voltage drop, that is a Vg, this is galvanometer, is equal to Vs. So as per Ohm's law, V is equal to IR. Now Vg is nothing but Ig into R, resistance is 5 ohms, okay, fine. Ig, we will no, we will not skip this, wait. So Vg, Ig into V is equal to IR Rg. Now here I value is I minus Ig, and if you multiply with S, now S is equal to Ig into Rg divided by I minus Ig. Now putting all the values as per given in question, Ig value is taken as 3, Rg is taken as 5, I minus Ig nothing but 10 minus 3, which is equal to 15 by 7. So that will give you roughly a value of, if you calculate, it will give you like 2.1 ohms. So shunt of 2.1 ohms, when we connect in parallel with galvanometer, then it will work as a ammeter. So the next question, if you see, they're asking, in a three-phase star connection, phase voltage is measured at 440 volts. What will the value of in line voltage? So as we know, this is theoretical or proven also as per the circuit diagram. So if you want that, it's available on YouTube also, and if you want, I will make a video separately on this. But always you should remember, so if they are asking like what will be the line voltage, so in case of star connection, VL is equal to root 3 times of V phase. Okay, so here VL is equal to root 3 times of 440 volts. So this will be your correct answer. So if you go for the next question, they are saying what will be the frequency of electrical supply when generator of 4 poles is used running at 1500 rpm. As we know, this is a famous formula. N is equal to 120 F by P, where F is a frequency and P is number of poles of a generator. Next, they're asking what will the frequency. So for that, frequency is equal to P into N by 120. So what will the value of P? Already given, 4 poles. Okay, 4 poles they have given. Now the N value 1500 rpm they have given by 120. If you solve these two, if you solve this one, that will give you a value of 15 Hertz. So the answer for this question is 15 Hertz. So if you shift to the next question, considering the frequency of AC power supply in Hertz, calculate the current frequency in Hertz of a complete cycle in a sine wave of output AC. So like this, they are using a lot of terms that may make you confused, but just focus on the data given. Okay. So sine wave means what? AC only. A cycle means a complete 360-degree cycle. These all things will confuse you. So now they're saying taking angular velocity as 350 radian per second. So angular velocity is nothing but a omega value. So omega is equal to 2 pi f. As we can see, already omega value is given. So 350 is equal to 2 pi f. And now f is equal to 350 by 2 pi. 350 by 2 into 3.14. If you solve these all things, you will get nearly 37.15 Hertz. So this will be answer. And maybe this answer is not correct in a given option. So everyone got grace mark also for this. So no issue. Just take a concept. Now, if you go for the 18th number question, there are 3 batteries. This question make many of you confused. So just listen carefully. There are 3 batteries connected together as shown below. Just to take example, there is a 3 battery connected together as shown below. Like in parallel connection, they are shown in figure. You can just refer your question. Now they are saying that each batteries have a 3 cells. One battery is equal to 3 cells. They are having a 3 cells, and one cell voltage is equal to 3 volt. So by this, one battery summation of all 3 cells will give 9 volt. Now they are saying 3 battery in parallel connection. Always remember, in parallel connection, the EMF will be same, the output EMF will be same. Okay, so we can see if you connect all 3 in parallel, this will give you a same voltage. So in parallel connection, we are having 9 volt. So option is 9 volt is only correct. So in case we are having condition like series, in that case, what is happening? Your voltage get extended. Okay, like 3 batteries in series. So 9 plus 9 plus 9 is 27 volt. But in parallel connection, ampere hour getting increased, means capacity of a battery is getting increased. Like if you take ampere hour, what is ampere? Is the capacity of battery, that will increase. Okay, so next we will see next question. Find the resistivity of a copper conductor carrying a current of 5 amps in a DC circuit and supply voltage available is 20 volts, where the throughout length of conductor is 1 meter and also have a unit area of cross section. Many of you, if you read this all question, you will get confused, but if you have a basic concept that they are saying to find the resistivity. So resistivity, that is rho is equal to RL by A, where R is the resistance of a conductor, L is the length of a conductor, A is the area cross section of a conductor. So already they given area 1, unit area, length 1, R they have not given, but they have given a value of what? Current. I is equal to 5 amps and volt is equal to 20 volt. So from, as per Ohm's law, V is equal to IR. So R is equal to V by I. So if you find this V by I, 20 by 5, this will give 5 4 the 20. So 5, what is the value? Ohms. Now if you put here, rho is equal to 5 into 1 by 1 is equal to 5. So 5 will be the answer. Next, if you shift to the next question, a copper coil having a resistance of 100 ohms carrying a current of 10 Mbps. 10 amps. How much the heat will be get dissipated if the current allowed to pass for 1 minute? As we know, we are using a lot of heater, geyser, Maggie. We are making a Maggie in that using a coil, copper coil or like something. There is a heat dissipation occurring. What is that heat dissipation? Dissipation. Nothing but a power loss. Nothing but as per a Joule's law of current. Current Joule's law says, what current Joule's law say? H is equal to heat dissipated when any current flowing through the circuit is given as I square RT. So already they have given you I value. What is the I value they have given? I value given 10 amps. R value they have given 100 ohms. And time given 1 minute. So standard is second. So we will convert to 60 seconds. Now we will put here 10 square into 100 into 60. So if you solve this one, this will give you around a value of 612,345, this much. So this will be converted joules. This is in joules. So if you go 600 kilojoules, this will be your answer. So if you shift to the next question, if there is a total number of coil mounted on armature of a generator is 100, then the number of conductor is equal to, always remember that number of conductor is equal to 2n, where n is equal to coil numbers. So 2 into 100, which is equal to 200, will be the answer for this. Now next question, calculate the speed of alternator having 15 Hertz frequency with a number of poles is 8. They are saying there is the magnetic poles number is P is equal to, magnetic number poles P is equal to 8 poles, and the frequency they have given 15 Hertz. Now they are saying what is the speed of generator, what is the speed of alternator. So there is a formula well known, what n is equal to 120 F by P, which is equal to 120 into 50 by P is 8 poles. So 2 4 are 8, 25 times 4 3 are 12, 30 is equal to 30 into 25 is equal to 750 rpm. So the answer will be 750 rpm. If you go for the next question, the prime mover of an AC 2-pole main propulsion generator drives the generator at least this. First of all, this question is divided into two parts. So we'll solve first part. The prime mover of an AC 2-pole. Okay, alternator prime mover of AC. Alternator has a number of pole is equal to 2. Now they are saying they are rotating at a speed of n is equal to 3600 rpm. Okay, so from here we will take frequency value. N is equal to 120 F by P, whereas F is equal to P into N by 120. P is 2 into 3600 by 120. If you cut like this, 12 3 times 13 into 2 is equal to 60 Hertz will be the frequency. This is the first part we already solved. Now we will solve the second part of this question. They are asking, if the main propulsion motor has 80 poles, pole is equal to 80, what will be the propeller speed? What will the propeller speed? They are asking n value. Okay, frequency value we already taken this 60 Hertz. Okay, so from here if you calculate, n is equal to 120 F by P, so is equal to 120, frequency is 60 and P is your 80. 0 0 gets off, 2 4s are 8, 2 6s are 12. Okay, 6 6 are 1 second. Okay. So if you 4 4 12, 1 second, I just got confused. So if you go and solve this one, so it will give you 120 into frequency is 60 by number of pole is 80. If you solve this one, the final give you 19 rpm value. Okay, so the answer for this is propeller speed will be 19 rpm. It will not 3600 rpm. Okay, so this is very good question. You should understand how the propulsion, electrical propulsion working on board. Okay, this question for that only. So if you move to the next question, what will be the clamp meter indicate if a clipped around a 3-core cable with a which is known to be carrying 200 amperes to AC motor? First of all, if like we are having three-phase supply, if we are having three-phase supply, 1 2 3, wait a second, 1 2 3, this is RYB, and if you take a clamp of a clamp meter, okay, this is a clamp meter, this will give you zero value because of the phasor value, that is a phasor value of 3, overall value will become 0. And if you want to measure a current, you have to take one coil and you have to measure for one coil. This is clamp meter. So the conclusion is, if you calculate measure all three wires, which is three phase, that will give you phasor value of 0. Okay, output. So always measure of a, only take a, like you can measure at a once B value or Y value or R value. So if you're moving to the next question is something a resistance of 15 ohms heated from temperature 20 to 35 degrees Celsius. A resistance 15 ohms is there. First it is having a 20 degrees Celsius temperature, now it is heated up to 35 degrees Celsius. If the temperature coefficient of resistance, that is the alpha value they have given you, alpha value is equal to 0.004041, then what is the new value? They are asking the new value of R. So as we know, coefficient of resistance, we know thermal coefficient of resistance, R nu is equal to R difference. R nu is equal to R difference 1 plus alpha T2 minus T1. No, nothing but T minus reference. Now we know that T reference is 20 and T temperature, which is increased 20, increased to 35. Now R reference value they have given, R reference value you can take as a, R reference value they have given you 15 ohms. Okay, so R reference is 15 ohms. Now if you put all values here, R reference is 15, 1 plus alpha value is 0.004041. Now what is 35, your T2 value, and minus T reference is 20. Solve this all. If you solve this, you will get a value of like 15 into, sorry, you will get a final value 15.909 ohms. So after increasing the temperature, you can see from 20 to 35, the resistance value is increasing. Initially it was 15 ohms, now it is increasing to 15.9, that is around 60. So this will also give you a concept. This is very good question. You should know how